Welcome to my video on wave speed. We're going to be learning about the wave speed equation here, and waves have speed just like a car or a person can have speed when they're moving. And we can look at any part of the wave, but if you focus on the wave crest, it makes a little bit more sense. Think of the wave crest like a car. I'll try to draw a car that is moving, right, in a certain direction. That's a funny little car. And so it's going to move at a certain speed, right? So basically, it would just be the same equation that you would have for speed in general. Oops, what was that? It's over time, distance over time. But we can do some rearrangement of the different variables, and what we end up coming up with is more specific to waves, and that is wave speed equals frequency times lambda. Lambda is also known as wavelength, okay? And if you look at this picture, you'll see that wavelength is the distance between two wave crests or any two identical points on a wave. So one way that I like to look at a wavelength, here it's measured from crest to crest, but you could also draw a line right here and right here, okay? As long as it's the same point, you can see here I've made an X and here I've made an X. This would also be one wavelength, and it can also be called a wave cycle. All right, so it's just one complete wave. Wave speed is equal to frequency times wavelength. That's a very important equation. All right, so now we're going to move on to the definition of frequency. And let's see, whoops, there we go. Get that out of here, and here's frequency. So we said lambda is wavelength. Frequency is just how many wave cycles move past a point in 1 second. So if you look at this picture here, like I said before, a complete wave cycle is, we'll put an X right here and an X here. That's one complete wave cycle, right? And in this picture here, they're saying that this entire distance of wave that's shown takes place in 1 second. So we can see that there are two wave cycles or wavelengths in this 1 second interval, and that is why here we have a frequency of 2 hertz. All right, so frequency.
George to the back side of the kitchen. George to the back side of the kitchen.
Sorry about that. Frequency equals waves per second. And the unit we use for that is hertz. Now we're ready to work some wave speed problems. This is a worksheet that you should have on wave speed right here. And it has the basic equation for wave speed written at the top here. So that's wave speed, which is V, equal to lambda wavelength times F, which is frequency. You have all three variables here and the units for each one. Wave speed is in meters per second. Wavelength is in meters, and hertz is the units for frequency. Now, sometimes you will be asked for wave speed, and when you are, you can just remember that basic equation, lambda times F or F times lambda, same thing, all right? This is multiplication here. But you might sometimes be asked to solve for wavelength and other times asked to solve for frequency, right? So it's going to be important to know how to rearrange this equation, and that's what the wave speed triangle is for. So if you look at the wave speed triangle, you're going to have wave speed on the top, and that is because wave speed is always going to be on the top when you're doing a division problem. It's going to be V divided by frequency or V divided by lambda if you're trying to find the other variable. However, we know that when we're solving for wave speed, we multiply frequency times wavelength, right? So it shows the relationship between those different variables if you were to use algebra. The way to use the triangle, though, if you find the algebra part a little confusing, is just to circle the thing that you're looking for, and the triangle will show you the relationship between the remaining variables. So when I'm looking for velocity, right, which is the same as speed, I'm going to use this equation here, and the wave speed triangle shows me that velocity is going to be equal to frequency multiplied by wavelength. Okay, so now what if I'm looking for frequency, right? So write frequency, whoops, I got to not write that right there, frequency. Then I'm going to look at the relationship between V and lambda. And the wave speed triangle tells me that to find frequency, I'm going to take V and divide it by lambda, which is wavelength. So I would write this equation out as frequency equals V divided by lambda, wavelength. Okay, let me just erase that so we can look at another relationship, and that's how to solve for wavelength. So you may know what the answer to this is now, but then if I want to solve for wavelength, I'm going to circle, let me get my correct instrument here, circle wavelength, and I can see from the triangle then V is on top and it's being divided by, so I've got V here, wave speed, divided by frequency, and here's my division symbol. Whatever's on top is going to come first when you write out the equation. So lambda will equal V divided by frequency. And those are my three equations. This is at the top of your worksheet, but the triangle is not there, and neither are these equations. So you might want to write these down, all three versions of the equations. Okay, so now we're going to go ahead and work some sample problems. So first sample problem is right here. You should have this one. It's just from the wave speed equation worksheet that you have. And it says a wave with a frequency of 14 hertz has a wavelength of 3 meters. At what speed will this wave travel? So I'm going to make a column called known and a column called unknown. And this is an approach you can use for any physics or math story problem. All right, so then I'm going to go through here. I'm going to circle the number, and I'm going to underline the word that tells me what this number is. So I've got 14 hertz, that's frequency. I've got 3 meters, that's wavelength. And then at what speed, I'm going to put a box around speed because speed is what I'm looking for. So my knowns then are frequency is equal to 14 hertz, and wavelength is equal to 3 meters, and my unknown, speed, right? And I usually put a question mark for my unknown. I know the thing I'm looking for is speed. I'm going to circle that, look at the relationship between the remaining two variables. That's going to be frequency times wavelength. So I write out my basic equation without the numbers first. Frequency times wavelength. Then I'm going to put my numbers in. V equals 14 hertz. And I usually just write it like this with parentheses to show multiplication, times 3 meters. All right, so some of you may be able to do that quickly in your head, and I happen to know that this comes to 42. All right, so wave speed is going to be equal to 42, and if you look at the top of your sheet, you'll see the units on that. Velocity, any kind of velocity, including wave velocity, is also always going to be in meters per second. All right, so that's the answer to this problem. Next. Okay, so this is another wave problem. We're going to take the exact same approach. I'm going to write a known and an unknown column. And I'm going to circle my number and underline what it is. So I've got 65 meters per second, that's speed. I've got 0.8 meters, that's wavelength. And I'm going to look for frequency. That's why I'm putting a box around frequency. So my knowns are speed, v equal to 65 meters per second, and wavelength, lambda, equal to 0.8 meters. My unknown frequency is equal to question mark. Since I'm solving for frequency, I'm going to circle that variable and look at the relationship between v and lambda. So v will always come before lambda in the division problem. So it's going to be frequency equals wave speed divided by wavelength. That's going to be frequency is equal to 65 meters per second divided by 0.8 meters. And so if we solve that, I've got to use my calculator this time. 65 divided by 0.8, I end up with 81.3, and frequency will always be in hertz. You can look at the top of the worksheet if you don't remember that. There we go. That's the answer to number 2. And so now